Okay, today we're going to look at Lesson 3, which comes from Section 1.4 out of your textbook, and our learning objective is I can solve equations. So this section, today's lesson, is going to focus on solving equations. You've been doing that for a while now, so it shouldn't be new information. I know you did it in Algebra 1, and you were probably doing it even before then. We do have 3 vocabulary terms today. Solve, which is just to find the solution. A solution is a value that makes an equation true, and an equation is just a math sentence that states that 2 expressions are equal. So here's an example. This expression is equal to this expression. Okay? So take just a second, pause the video, and write that vocabulary down. Okay, now we're going to talk about some important things to remember when you're solving equations. Okay, so we just have 4 little reminders here. The goal of solving an equation is to get the variable by itself. You need that variable all by itself on one side of the equal sign in order to have the solution. The golden rule of equations is what you do to one side of the equal sign, you must do to the other. So if you decide to multiply one side by 5, you have to multiply the other side by 5 as well. Same with addition, subtraction, division. If you're wanting to undo an operation that's shown in the equation, make sure you do the opposite. So if there's addition in the problem, you undo that by subtracting. Okay? And the opposite of multiplication is division, and vice versa. So always do the opposite of what's there to undo it. And then last, a little tip, because sometimes people get a little ahead of themselves and they try to multiply or divide before they need to. So a good rule of thumb is to just wait until there's one term on each side of the equal sign before you multiply or divide. Okay, that last multiplication or division should be your last step before the equation is solved. Okay, now would be a great time to pause the video, make sure you have these 4 important notes down, and then copy down these steps. I've made just a general list of steps that you can follow when solving equations. Some of your equations might be 1 step, some of them might be 4 or 5 steps. But if you follow this list and you work through this order, then it should work every single time, no matter how big or small your equation is. Okay? Now, it's very important that you write these steps down because most of you are going to need them at least maybe once or twice until you get the hang of it. Again, because it's been a while since we've done some math, so you might be a little rusty. Okay? Now, what I do want you to know is that these are guidelines, okay? Many of you probably already know, or you will see that you can solve the equations a little bit differently than me. You can do a couple steps out of order. You and your neighbor can work it out a little bit differently and still get the same answer, and that is perfectly fine. You do what works for you. But these 5 steps are just a basic guideline that you can follow if you get stuck or you don't know what to do or you don't remember what to do, anything like that. So when we work through some examples here in a minute, I am going to follow these steps. I'm going to go in this order. But you might notice I might do something a little different to make it a little bit easier. And if you see something different that will make it easier for you, by all means, do that. Okay? These are not set in stone concrete steps, okay? Just a guideline that you can use. So take just a second, if you haven't already, pause the video and write these steps down so you can use them later. Before we start looking at some examples, we need to talk about the different solution types that you could get when you're solving equations. Our most common answer will be a variable equals a number, like x equals 2 or y equals -3, something like that. And so if you get a variable equals a number, then that is the solution that you're going to leave on your paper, okay? And it's important to note that when you get a variable equals a number, that means that sometimes that equation is true. It's only true when you use the correct number for the variable. Okay? The next type is no solution. That's when you have when you end up with 2 numbers that are not equal. 5 never equals -3. So that's a no solution. And so that means that the equation is never true. No matter what you do, it's not going to work. It's never. The third option is infinite solutions, and that's when you get the same thing on both sides of the equal sign. And I should have added, you can also get something like x equals x or 0 equals 0. Okay, as long as both sides of the equal sign are exactly the same, that's infinite solutions, and that means that the equation is always true. No matter what you do, it's always going to work out. Okay, so you guys have probably seen these three types of solutions before and you've worked with them, but today we're going to throw in the sometimes, never, and always true option, because in your Math Excel work, there are some questions where you're going to have to solve an equation, and then what it wants to know is if it's sometimes, never, or always true. So all you have to do is look back here at your little solution, so make sure you write them down. If you get a solution, it's sometimes, no solution is never, infinite is always. So again, take just a second, make sure you get that written down. Okay, the rest of our notes are just going to include some examples. So we're going to start with some one-step equations and build. We'll do two steps next, and then we'll get into some multi-step equations. So as we go throughout the rest of the video, I recommend that you pause the video, try these examples on your own, try them in your notebook, and then come back with me to check your answers. Okay? Again, this should not be brand new information. So hopefully after you practice a couple, you'll get right in the swing of things. I will also include some extra practice problems if you want to practice a little bit more on your own before you actually do the Math Excel homework. Okay, so these are your first three examples. Go ahead and write those down for me and pause the video and give them a try. Okay, hopefully you've had a chance to practice them. You paused the video, gave them a try. So number one, we have x minus 11 equals 9. We need to undo this operation to get x by itself. So we will add 11 and we get x equals 20. You can always check your answer by plugging this number back in for your variable. So in this case, we would have 20 minus 11, and that does equal 9. So that is correct. All right, number two, we have negative 6 plus y equals 0. This one, or problems like this, are tricky often because we see the plus in the middle, so that means we need to subtract. But really, we need to look at this number that we're moving to the other side. So if we have a negative 6, the opposite of negative 6 is positive 6. And so that gives us y equals 6. Again, you can check your answer. Negative 6 plus 6 does equal 0. And then number 3, we have x divided by 3 equals negative 6.3. So we can multiply both sides by 3. Those divide out. And we're left with x equals negative 18.9. Oh, and I forgot to box that. Sorry about that. So those are one-step equations. So you just have to do one thing, one step before you get your solution. Okay, those are our most basic equations that we're going to solve. Now we're going to look at some two-step equations. Two steps are pretty straightforward. You have to do 2 steps to get the variable by itself. So you're going to have to do some addition or subtraction and then multiplication or division. It's like doing the order of operations backwards. Okay, so pause the video, try these on your own. And now hopefully you've had a chance to try them, and let's see what answers you should have. So 2x plus 1 equals 7. So the first thing we need to do is the addition or subtraction. We're going to get rid of that positive 1 by subtracting 1, and that gives us 2x equals 6. Then we have one term on each side. Remember, we made a note, wait to multiply or divide until your very last step when you have one term on each, and we do here. So we have 2 times x. To undo that, we divide by 2, and we get x equals 3. Okay, number 5. Again, we do addition or subtraction first. So this negative 1, We're going to get rid of it by adding 1 to both sides. We have x over 2 equals 6. Then we're dividing by 2, so the opposite would be multiply by 2. These divide out, and we're left with x equals 12. Okay, and number 6, again, addition or subtraction. We've got a plus 4, so we're going to subtract 4. And that gives us negative 3x equals negative 21. Then this messes people up sometimes because they want to add the 3, but if you look at the operation that's happening, that's negative 3 times x. So the opposite of multiplication is division. So we're going to divide by negative 3, and we get x equals positive 7. Okay, so there are some two-step equations. Okay, our next two problems add another little step. So we're going to think through our steps that we wrote down in the previous notes. And another thing that might be helpful, I've said this before, I like it because it keeps your work organized, and it really helps a lot of you visual learners keep things where they're supposed to be. So it might be helpful to draw a line down through your equal sign. When you get into the multi-step problems, if you want to draw a line through your equal sign, that kind of helps you see which side things are on. And again, that's just a suggestion. You do not have to do that by any means. But let's think through our steps. Step number 1 is use the distributive property if needed. We look at the problem. We don't need the distributive property because there are no parentheses. Step number 2, combine like terms on each side of the equal sign. So I look on this side. I do have some like terms. I have 3x and positive x. So 3x plus x is 4x. And then I'm just going to bring everything else down. There are no like terms on the other side, so I'm just going to bring the 16. Now we're left with a two-step equation. So subtract 4, and we get 4x equals 12. We divide by 4 and get x equals 3. Okay, so that one, you can see how I was thinking through the steps and I was working through that process. All right, now pause the video, give number 8 a try, see what you can do on your own. Okay, hopefully you've had a chance to try it. Let's see what you should have. Step 1, distributive property. I do have parentheses, so I do need to distribute. I'm going to distribute the 5 to everything inside. So 5 times x is 5x, 5 times 2 is positive 10, and then I'm left with a 60. Step 2, combine like terms on each side. I don't have anything alike on either side. Step 3, move the variables to one side of the equation, or just solve the two-step. Okay. Oh, my bad. Let me backtrack. There's only variables on one side, so we skip step number 3, and number 4 is when we move the constants to the other side of the equal sign, and that's what I meant to say. So we're going to take this 10 and subtract it, so we get 5x equals 50. Then we can divide by 5 and get x equals 10. And remember, you can always check your answers by plugging that number back in for the variable. Here are equations 9 and 10. I want you to pause the video, give these problems a try, see if you can figure out what to do, follow the steps that you were given, and see if you can come up with an answer. And then we'll check them together here in just a second. Okay, hopefully you've had a chance to give these a try and you pause the video. I am going to draw a line down through the middle of my equations because this time I have a lot of stuff on both sides of the equal sign, so I want to make sure everything stays lined up and organized. So on number 9, let's think through our steps. Distributive property. There are no parentheses, we don't need it. Step 2, combine like terms on each side. Look at the left, nothing's alike. Look at the right, nothing's alike. We can move on. Step number 3, move variables to one side of the equal sign. All right, we do have x's on both sides, so we need to move them all to one side. Now, there's a couple different ways you can go about this. You can always move the variables to the left. You could always move the variables to the right. You could look at the numbers that you have and see which one's going to leave you with a positive or which one's going to leave you with a negative. You've got a lot of different options, but you can do it a few ways and still get the correct answer. So for this one, I'm actually going to move this 2x to the left. And this is a positive 2x, so the opposite is negative. So we're going to subtract. 5x minus 2x is 3x. Now, I want you to notice we line the x's up with each other. We couldn't subtract the 2x from the 2 because they're not alike. So that's why I put it with the 5x here. So did that subtraction and we're left with 3x. We bring down the plus 2. These cancel out and we're left with 14. Okay? Now, it's a two-step equation, or you can think through your steps. Move the constants to the other side. So we move the variables to the left, we move the constants to the right. If we have a positive 2, we subtract it and get 3x equals 12. Divide both sides by 3, and we get x equals 4. Okay, number 10 is very, very similar. 7k plus 2 equals 4k minus 10. Again, I don't need the distributive property. I don't have like terms on either side. So I'm going to go straight to moving all the variables to one side. Okay. 4 is less than 7, so I'm going to move the 4 over to keep my k's positive. 7k minus 4k is 3k plus 2 equals negative 10. Okay. Next, it's just a two-step, so solve it like a two-step. We've got a positive 2, so we're going to subtract. And we get 3k equals negative 12. We can divide both sides by 3 and get k equals negative 4. And I'm just now realizing how similar these two problems really are, but that's okay. That means just more practice of that same type of problem. Okay, next we have problem 11. This one has a little bit more stuff going on. I am going to draw a line down through my equation, and let's think through our steps together. So I want you to work this one out with me as we go. Step 1, do I need the distributive property? Yes, here's a set of parentheses. So I'm going to distribute 4 to everything inside. 4 times 10x is 40x. 4 times 12 is 48. And I'm just going to bring down everything else. Now, I'm going to look on either side and see if we have like terms. Okay, there's none on the left. There's none on the right. I can just keep going. So now I need to move all of my variables to one side. I'm going to try to keep my x's positive. So I'm going to move this 10x with the 40x. So I'm going to subtract 10x. And I have negative 12 equals 30x plus 48. Now we have a two-step equation, so you can think of it as a two-step, or move the constants to the other side. So we move the variables to the right. We're going to move the numbers to the left. So I'm going to subtract 48 from both sides. I have 30x equals negative 60. We're down to a one step. We divide both sides by 30, and we get x equals negative 2. Okay, so there we used almost all of the steps. We did have the distributive property, and we had to move variables and numbers to the same side. Okay, so what I want you to notice, I know we've done a lot of examples already, but I think it's important that you see a lot of different examples so that you can apply those to a lot of different problems. But something I want you to notice is that so far all of our equations have had a solution. We've got a variable equals a number. So all of these equations would be considered sometimes true. They're true when you use the correct number for the variable. Okay, so remember, if you get the variable equals a number, then it's sometimes true. Okay, sometimes true. So we are going to switch gears a little bit, and we're going to look at maybe getting some other types of solutions as we practice solving equations. Okay, so number 12, we have 9m minus 4 equals negative 3m plus 5 plus 12m. I'm going to draw my line first just to keep everything organized. Do I need the distributive property? No. Step 2, combine like terms on the same side or on each side. I don't have anything that's alike over here, but I do on this side. I do on the right. So I have negative 3m and 12m. If I just combine those together, I get 9m. So I'll bring that down. Bring the other side down. Now, some of you might be able to look at what I have here and already see what's going to happen. Okay, if you don't already see what's going on, then we can keep going. So we can move our variables to one side. So I'm going to move them to the left. So minus 9m, that cancels. I have negative 4 equals. That cancels, and I'm left with a 5. Ooh, does negative 4 equal 5? No, it doesn't. So our answer for this one would be no solution. And remember, if you get a no solution, that means that that equation is never true. Okay, it never will work out. Never, ever. Okay, now we're going to work out number 13. You can pause the video and try it for yourself, which is what I recommend. But if you want to stay and work it out with me, you can do that also. I just ask that you do work it out with me. So I'm going to draw my line down the middle just to keep it organized. Do I need the distributive property? Yes, I have parentheses, so I'm going to distribute 1/2. Half of 6 is 3. Half of 4a is 2a. And I'll bring down the other side. Now, some of you can probably look at this and know what's going to happen. You can tell me what the answer is going to be, and you can stop. And that's perfectly fine. If you can see it there, by all means, write the answer down and go on. If you can't see it, I'll just tell you. Those are the equal expressions. 2a plus 3 is the exact same as 3 plus 2a. Right? But we can keep going. We can move our variables over. 2a minus 2a cancels, and we have 3 equals 3. 2a and negative 2a cancels. We're left with 3 equals 3. 3 always equals 3. That's a true statement. So here we have infinite solutions. And what I want you to remember, if you have infinite solutions, that means that the equation is always true. Okay? So no solution is never true. Infinite solutions always true. And those are what they look like with just your solution. Before you actually write your solution down, this is what your equation should look like when you get finished. Okay, these are our last 2 examples. I want you to pause the video and give them a try. See what solutions you can come up with. See what answers you get. And then restart the video and check your answers with me. Okay, hopefully you've had some time to check your answers. Let's work them out. So number 14, we're just going to draw a line down the middle, and let's think through our steps. So step 1, do I need the distributive property? Yes. Now, this distributive property can be tricky because most of the time people want to distribute the 8. But we have to look at what's right next to the parentheses, and what do we have? A negative. That's the same as having negative 1 outside the parentheses. So we're going to distribute that negative. When we distribute a negative, you can think through multiply by negative 1, or you can just take the opposite of what's inside. So the opposite of 3 is negative 3. The opposite of positive y is negative y. I'm going to bring down the 8 and everything else. Now, combine like terms on each side. On this side, we have 8 minus 3. 8 minus 3 is 5. We bring down the minus y. This side, there's nothing that's alike, so just y minus 9. Now, we need to move our variables to one side and our numbers to the other. So on this one, I've got a negative y and a positive y. I think I would rather take this negative y and put it over here, just to keep my y's positive. So I'm going to add y to both sides and get 5 equals 2y minus 9. Now, it's just a two-step, or you can think of bringing the constants to the other side. So I'm going to add 9. I get 14 equals 2y. I have a one-step. My last step is to either multiply or divide. Here I'm multiplying, so I will divide by 2 and get y equals 7, or 7 equals y. And then number 15, again, I'm going to draw my line down the middle. This one's a little bit different. Do I need the distributive property? Yes. How many times do I need it? Twice. So let's look at the left side first. We're going to distribute this 5. 5 times y is 5y. 5 times negative 4 is negative 20. On the other side, let's distribute the 7. 7 times 2y is 14y. 7 times 1 is 7. Okay. Now, check each side for like terms. We don't have any on either side. So now let's get the variables together. You can bring 14y over to the left, or you can take 5y to the right. I'm going to choose 5y just because I want to keep those y's positive. So I have negative 20 equals 9y plus 7. Now it's a two-step, or you're bringing your constants to the other side. So we're going to subtract 7. So we have negative 27 equals 9y. And again, we're going to divide. So divide both sides by 9. And you get y equals negative 3, or negative 3 equals y. And that's your final solution. So both of these are sometimes true. So if you want to make a note, just like we did on those others, those are sometimes true because you have to use the right number for it to work. Okay, so I know we've done a lot of examples, but it's important that you know how to solve all the different types of equations. Again, I'm going to include some extra practice with this assignment or with this lesson in Google Classroom. You do not have to do the extra assignment. It's just there if you want more practice before or after you do your Math Excel work. Okay, so remember, if you need me, email me, contact me through Google Classroom or Math Excel, and I would be happy to assist you in any way. Have a great day.